Good day, everybody, and welcome to today's webinar. This session will begin at the top of the hour.
Hello everyone, here we are at the top of the hour, time for the webinar Manufacturing USA Institutes. I'm your host, Mike Lasecki, speaking to you from the Maricopa Community Colleges in Phoenix, Arizona. It's my pleasure to welcome you and your colleagues to this event. Here's some of the details of the webinar. Many of you are familiar with the Adobe Connect system that we're using today. You'll be in listen-only mode. But please ask your questions via the chat window. You can make comments there, you can share information, and this webinar will be recorded. You'll automatically receive a link to the recording. We gratefully acknowledge our support from the National Science Foundation, and this webinar is brought to you by the Florida Advanced Technological Education Center for Manufacturing, that's FLATE, the NSF ATE Centers Network, with support from the ATE Collaborative Impact Project. Thank you again for joining today. Before we get started, I want to ask you a question. So here's poll number 1, and let's put it up on the screen. Let's test, or rather ask for your feedback on your current knowledge about today's topic, the Manufacturing Innovation Institutes, often called the Manufacturing USA Institutes. So what's your knowledge? Is it pretty good, or the fourth choice is sort of a tongue-in-cheek one? But I'm very interested in knowing what you would like to know today. You can see the results rolling in. Most of us are here to learn about them. So that's perfect. That's the idea of this webinar. So I'm going to stop that poll for just a second and ask you one more question. Here's our second poll. This is sort of test your knowledge question. How many manufacturing innovation institutes are there today? Is it 3, 8, 14, 19? Let's see what you think. Okay, so I've got a lot of interesting choices. I think we're going to elucidate or illuminate, I'm not sure the right word, the answer here. But most of us think there's somewhere between 8 and 14 manufacturing institutes today. Thank you for responding to the polls, folks. We're going to address that question in just a moment. Let's move forward. It's my privilege to start by introducing today's lead presenter, Dr. Marilyn Barger. She's the PI and Executive Director at FLATE, the Florida Advanced Technological Education Center. Marilyn, why don't you come on and take us forward? I know you're not going to introduce everyone in detail at this point, but go ahead. The webinar is yours.
All right, thank you, Mike, and thank you, everybody, for joining us this afternoon. I'm going to let the presenters introduce themselves when we come up to their sections, but you can see we have Dr. Celeste Carter from NSF, and then we have 3 workforce and education lead directors of 3 of the different manufacturing institutes, Manufacturing USA Institutes. We're going to talk specifically about their own activities and programs going on within the institutes related to workforce, of course. So I'm going to move ahead and move on. So the idea for today is I'm going to give a little background about the institutes, and then each of the presenters are going to give an overview of their own institute and their workforce activities. And I've asked them to talk about the specific technologies, because a lot of them are pretty way out there, what they're focused on, and then what their workforce initiatives are, and then try to zero down on some of the 2-year technician programs that us in the NSF ATE community are particularly interested in. Okay, so looking back, questions of why manufacturing institutes might come up. So in the kind of depths of the recent recession, We're looking around for ways to create more jobs, and the President's Council, Advisors on Science and Technology, identified the issues that you'll see here, that we really could use opportunities to create collaborative spaces for industry and academia to work together to solve problems and lower that pre-competitive expense for applied research and development in a lot of different areas. Also there's a need to lower the risk for introducing new technologies and materials into the manufacturing sector. And all of this was summarized in the RAMI Act in 2014, making those official. So this was the motivation, and the institutes that were defined were given these 4 broad goals: to increase competitiveness for U.S. manufacturing, and also to facilitate transition of some new technologies into cost-effective and high-performing domestic manufacturing capabilities. I'm going to skip down to the last. They wanted to support new business models to help the institutes continue on their own after federal funding would stop, and so they're working on those models. And lastly, and most importantly, from our point of view right now, is the workforce, the focus on developing the workforce for advanced manufacturing. That was one of their 4 strategic goals. This is the group of current Manufacturing USA institutes. So I'll let you just take a look at this, but you'll see in each of the boxes the acronym. Let's see if I can drag this guy down here. So ARM, for example, is very new. Just was funded early this year, in January or last December, and it's focused on advanced robotics. It's located in Pittsburgh, Pennsylvania. So that's what the information that you'll see in each of these boxes here. So they're on all aspects of advanced manufacturing, some on processing, some on products, some on technology. This one looks really interesting, advanced tissue biofabrication in Manchester, New Hampshire. This one's also very new, just not even 6 months old yet. So advanced fibers, etc., as you walk around the map. That guy there for a minute. All right, so this is what the network looks like today. There's 14 institutes, so some of you got that right on the second poll that Mike Lasecki had at the beginning. There's $1 billion federal dollars invested that are being matched now by over $2 billion from the non-federal sectors. There's multi-agency funding for these institutes, the Department of Defense, Department of Commerce, Department of Energy, the National Science Foundation. I believe agriculture is in some of these, and I'm sure I'm leaving a few out. But it's interagency funding supporting these various institutes. So this says there are 8 active institutes, and those are the ones that were funded, I think, before December, this past December 2016. And at this point in time, they had 1,300 members. That's organizations that are actively engaged with those 8 institutes, and 240 technology projects are currently underway within those 8 institutes. Now, the more recently funded institutes are starting to roll out projects, I believe, as we speak this spring, so that number is going to go up quite significantly with 6 additional institutes. So you can see, just for some demographics, that the members include 2/3 of the Fortune, this is supposed to be 50, not 500, sorry about that, 50 U.S. manufacturers, and 8 of 10 of the top-ranked research and engineering universities. Many are involved in multiple institutes, many companies are, and many universities, research institutions are involved in multiple institutes as well, depending on where their research, some of their strong research focuses might be. So a lot of activity, and trying to keep up with them is quite a challenge. But recently, just to kind of close out my little section, there was a outside review done, let's see, by a outside third-party reviewer that had these kind of points to say about the institutes as they're entering. I think this will be their 5th year, going into their 5th year. That they have spurred a lot of research and development and innovation. It's been effective in creating ecosystems and conveners of parties that were interested in particularly technologies and pushing those technologies forward for a variety of reasons, and that they've leveraged a lot of dollars, so that's a good thing from the private sector. And then they also are working on some good strategies for sustainability. For some of the institutes, it's a little early for that, but those that have been funded for a number of years are putting into place strategies to continue after federal funding ceases for them. I believe that's my last slide. So I'm going to introduce or turn this over to Dr. Celeste Carter. She's the director of the NSF ATE program, which has an interest in this area as well. So, Celeste?
Okay, well, thank you, and welcome, everyone. So as Marilyn said, I am at the National Science Foundation, and I am the lead program director for the Advanced Technological Education program, which is in the Division of Undergraduate Education, and I'm one part of the response to the Manufacturing USA Institutes at the National Science Foundation. For all of those who are interested, I will tell you to please keep an eye on the website, because there is another Dear Colleague letter coming out for from the Engineering Directorate. So with that, I don't want to take too much time. I want to just give you a little bit of a brief overview of what the ATE program is all about, and tell you a little bit about the opportunity of the ATE community partnering with Manufacturing USA Institutes. And Mike or Janet or Marilyn, I'm not sure if I actually have control of the slides, or thank you. So very briefly, just do one quick step back in history, so to speak. In October of 1992, Congress passed the Scientific and Advanced Technology Act of 1992, and President George H.W. Bush signed it into law. This mandated the National Science Foundation to develop the ATE program, and 1993 was used for planning the program. First awards were made in 1994. So this is a program that will be entering its 25th year with fiscal year 18, and the initial program budget has increased from $13.5 million in fiscal year 94 to $66 million in this current fiscal year 17, and yay, we have a budget. So just a little addition there. So over the course of these past 24 years, this program has supported awards in all of the states and several U.S. territories. The ATE has reached almost 40% of the community and technical colleges in the United States, and that might be a little bit of an underestimate, because when you're querying the NSF database, it's kind of hard to capture 2-year campuses that are part of a 4-year system. So if I can have the next slide, this just tells you a little bit more about the program. It is a program that supports the education of a highly qualified technical workforce for the advanced technology industries that keep the United States globally competitive. Community and technical colleges are placed in leadership roles, or have to be in leadership roles, on all projects and centers. And really one of the main things I'd like to stress is the fact that this is a program about partnerships. So when you look at the Manufacturing USA Institutes, and they're developing new partnerships between industry and 4-year institutions. This is a program that has a long history of developing partnerships between 2-year degree granting institutions and industry, along with economic development agencies, the workforce investment boards, secondary schools, and kind of across the board. And it's also a program that's able to support pathways for students starting with grades 7 through 12, then 2-year and even 4-year. So that this is one of those programs that is truly hands-on, minds-on. Students gain a lot of academic rigor, but they also gain industry skills and competencies, and a lot of this is specifically driven by those industry partners. So if I can go to the next slide. Just a real quick overview of some of the lessons learned. So here we have a program that has 24 years of partnerships. People have used industry, and industry has partnered with this program in a number of different ways, everything from having industry scientists be hired as adjunct faculty and actually teaching courses on the 2-year campuses. They've been critical in developing skill standards across the disciplinary areas covered. They serve as industry advisory boards, and one particular type of industry advisory board is called the Business and Industry Leadership Team, where they actually drive changes in curriculum on a quarterly basis for some of the centers and projects. And they serve as mentors, both for faculty and for students. As far as the pathways go, one of the things that's happened is people are looking at stackable credentials. They're also looking at inserting the knowledge needed so that students are prepared to pass industry certifications. Transitions aligned. Basically, we want articulated pathways so that students can see that the goal is at the end of a 2-year degree or possibly even a certificate, students would be ready to enter the workforce and would be called highly qualified. And the other real, I think, really strong point for this program is that it works on hands-on and minds-on. So there's a lot of problem-based, case-based learning, a lot of work with industry, and people have thought carefully about integrating different work experiences. So one example is Salt Lake Community College that I think started the first contract research organization within the program. There are quite a few others. They also started a contract manufacturing organization. We have internships probably at almost every single project site, and there's at least one example of apprenticeships where the Smart Center, which is involved with the shipbuilding industry, has leveraged their registered apprenticeship program and integrated it into their center. There is a possibility that you can also go online at the nsf.gov website. There's a ribbon across the top of that site, and every single ribbon has an awards tab, and you can look at that to see some of the things that ATE has funded. So moving on real quickly to what are we doing with the Manufacturing USA Institutes, if I can have thank you, the next slide. There is a Dear Colleague letter that was published. I don't know how I ended up with this number, but it's easy to remember. It's 16-007. And this really describes an opportunity for the ATE community to work with not only the Manufacturing USA Institutes, which is our topic today, but also the Investing in Manufacturing communities partnerships. So there's 2 different ways that people can work with the institutes and the IMCPs. One is if someone has a current award through the ATE program, and they have contacted or are working with an institute or IMCP, and they agree upon a scope of work around workforce development and related to technician education, then they may submit a supplemental request for money to support the work that they will do with the institute or IMCP. The second opportunity is the submission deadline for the ATE program this year will be in early October. I believe it's October 5th. And project proposals can also be submitted that include these partnerships of a 2-year college with one of the institutes or IMCPs to be considered under the merit review process for the National Science Foundation. So with that, I think I'm going to turn it back to Marilyn, and we'll move on.
Dr. Carter, it's Mike. There's we have a few brief questions for me.
Sure, okay. So let me, I can see from Bjorn that he's got a question where it says, will it help my proposal funding chance if I have a letter from one of the institutes? You're actually, if you read that Dear Colleague letter, you are required to have a letter. And the letter has to say that they agree to the scope of work that you are presenting in your proposal. So that's a yes, it isn't just going to help you, it's required. And then from Laura, we have, are there different problem project case-based learning exemplars uploaded at the Creative Commons. The ATE program actually has its own digital portal and library, and that's called ATE Central. So it's atecentral.net. All projects and centers are required to archive their materials and have their materials at ATE Central as well. You can also find that a lot of people will have their own websites and use those initially to have their materials there. There's a pretty good percentage of ATE awardees who are also TACT awardees, so there will be some exemplars that will be on Creative Commons. And thank you, Janet, for putting up atecentral.net.
Thanks, Dr. Carter. We really appreciate your time in giving us that opportunity, the heads up to what's coming and additional ways of supporting our initiatives. For the interest of time, Celeste, we're going to move forward and invite one of the Institute partners, Brent Parmenter, to come on board. Brent, would you introduce yourself and tell us a little bit about Netflix?
Yeah, absolutely. Thank you, Mike.
You sound good, Brent. Thank you.
Yeah, thank you, everybody, for joining us today. So my name's Brent Parmenter. I'm the Director of Education and Workforce for NextFlex. We are out in San Jose, California. You can see from this slide, which is a different version of what was presented earlier. We are in the West Coast out here in California, headquartered in San Jose, but we're partnered with many of the other institutes, and this is just another version of that. Our technology overall is pretty simple. You think of a rigid green standard silicon circuit board, and we're all about going through the processes of turning that into a bendable and stretchable and flexible activity. And so it's mainly because the world isn't two-dimensional. Most electronics today, they're constrained by that form factor, and more we're seeing the requirement to have a customization of electronics for everything. And you can see some of the examples of what the technology allows you to do, and the transparency and the flexible, bendable, conformable components. It is all about combining these two different things to get us those different form factors that we're looking for. So the applications that we're mainly focused in are around human and health performance, asset and structural reliability. So think of being able to put flexible electronics into underground gas pipes or airplane wings to tell you about the structural health before something bad happens. Process tracking for agriculture industry is one of the big ones. There's others, soft robotics and prosthetics. There's quite a big application for the technology there, and then overall sensing technologies. Here's an example of the dual use technology that's a really neat story. So a few years ago, and our predecessor organization started working with the U.S. Air Force on figuring out how we could monitor the cognitive health or stress levels of Air Force pilots. And then it turned into a program for drone pilots, because they have these lethal payloads. They're in stressful situations, and you wanted to make sure that you had someone that was very focused and able to perform the tasks at hand. To do this previously, you used to have to do a draw of blood. You would analyze it, so it was very temporal, and it wasn't continuous, and it was somewhat disruptive during the activity in question. So here's this technology out that we're focused on nowadays that is all about doing that through a patch that you apply to the skin. Through a process of reading the biomarkers in your sweat, you can tell the same amount of information you used to have to do through the draw of blood. And it's through this flexible hybrid electronics technology. And you're wondering why there's this picture of a young newborn in the screen. Well, our executive director was at a conference called Blood, Sweat, and Tears, of all things, a great name for a conference of this sort. And a nurse from a premature baby ward said that technology would be game-changing. We can't draw blood from young premature infants. They just don't have enough. It's intrusive. This patch would save a lot of their lives. And so this is just, I give this, it's a great story. It's a good example of the dual-use technologies that are out there in the human and health performance monitoring space. And then there's equally impressive examples in some of the other spaces as well. So to integrate the workforce development into this, we're very much, as an institute, and all of us, focused on the research and development. We are focused on the dual-use commercialization of products and processes, as I just described, but we see the importance of integrating the education, workforce development, and training, and I've added in entrepreneurship into that, and so we see that as an integral portion of the Venn diagram. This has been our strategy within NextFlex for how we've approached the problem. You can see our main mission statement there. It is all about what the needs of our industry partners are. That has to drive us in a demand-driven process. We started out, after initially getting organized, focusing on what that supply and demand analysis looked like through the course of our first year, and then ran a series of pilot programs focused at the high school, community college, undergraduate, and then some outreach and recruitment initiatives. And I'll describe some of the first two today. We know that once we have the supply and demand analysis, we can then do a better job in our out years of delivering the results of that consistent with the operating agreement. And then once our cooperating agreement ends, we can do that in a post-cooperative agreement environment as well. So what we found through the course, this supply and demand analysis was just completed. We did it with an independent group that had done it for several of the other institutes, and we came to the conclusions that there are 60 occupations related to the core advanced manufacturing skill sets and flexible hybrid electronics. 9.5 million jobs in the U.S. with those 60 occupations, and about 1.5 million job openings in 2016 across those 60 occupations. The salary is pretty good. It varies. That's the average across the country. It is higher in some areas, lower in others, but that's a pretty good starting salary at the 2-year technician level. 22% women. We know we need to focus on trying to get decrease the gender gap that exists in advanced manufacturing, and that's a big part of what we're focused on, as well as the cliff that's coming with 25% of the people in these jobs, of these 9.5 million, are over 55 years old, yet we just aren't seeing the backfill with 6% under 24, and that's a big part of what we're focused on to get additional folks into the queue to take over while we still have that expertise with about 10 or 15 years left of work experience. So that's the snapshot of what it looked like in 2016, but we all know, and I'm probably preaching to the choir of the attendees in the room, we know what's coming, and we know based off of several factors, a drop in robotics prices in the next 2 to 3 years, the amount of tasks that robots can do now versus what will likely be done in the future in place of humans, and then the artificial intelligence explosion that's accelerating the process of, right now we have about 25 billion connected devices in the world, and that's going to accelerate to 50 billion or double in the next 5 to 10 years. You add all of that up, and you know there's going to be a huge amount of people that have the skill sets to operate in this robot economy that's coming. And it's specifically people that can design, manufacture, install, operate, program, maintain, and synchronize the machines that are going to be a part of our lives. And so our main focus has been, how do we teach people to be this person right here and ride that wave as opposed to get crushed by it? And we know it's not going to just benefit manufacturing. If we can do the outreach and some of the programs to get young people interested in these things and enter into those 2-year programs, they're going to benefit multiple sectors. One of the ways we like to equate this when people say, well, the robots are going to take all our jobs and there's not going to be any jobs. And that's not true. We know historically, look, 200 years ago, it took 100 people to pull the amount of crops out of a field. Now it only takes one to do that same job, but those other 99 people have jobs. They're just different jobs, and they aren't the same skill sets that were used to pull those crops out of a field. They're different skill sets, and we see ourselves on the cusp of a similar revolution. What we're focused on within NextFlex is, this is a pull from a book that was recently out called The Engineering Technology Education by the National Academy of Engineering. And I really like this diagram. We're focused on this side within NextFlex of our efforts and our resources. We think it's very much in line with what we talked about in the previous slide. And so we're focused on engineering technicians and technologists, and this highlight here really focuses and describes where our efforts have taken us and where we think we can have the greatest impact. So our central question comes down to, how do we get young people interested in these types of jobs and on the pathways to fill them in the future? And it's all about, it's not going to be one sector. We all know this. It's going to be a collection of public-private partnership in action and putting those puzzle pieces together. So I'd just like to talk briefly about an example program that we're doing right now in Silicon Valley with Evergreen Valley College and some area actors. We have on the left side of the slide a number of school districts within South San Jose, along with the county STEAM and CTE programs. We have Evergreen Valley College, which is our anchor. We have industry members here on the right, specifically in this case for our pilot program, Jabil and Flex, which are the world's second and third largest third-party manufacturers with a heavy presence here in Silicon Valley. And then we have our Workforce Investment Board, Work to Future, and the Silicon Valley Organization, which is the Chamber of Commerce for the area. And that's all built a partnership around both a community college activity blended with a high school activity that I'll describe briefly. What we've tried to do at the community college level with Evergreen, based off Evergreen approaching us, is how do we expand this skill bridge between high school talent pools and the four-year university programs or direct fill into industry. We know from talking with Evergreen Valley College that about 90% of the curriculum already exists along these three pathways here, or these three levels, to get people to the right step to enter this side of the equation. But what we've decided to do, and based off of demand with Evergreen, is ourselves with several of our fellow institutes, is take a look at those curriculums and then decide about 10%, how can we help augment that and add in things like industrial automation and the program and deploy of IoT devices and smart manufacturing and processes as example curriculum activities that Evergreen says they need based off of what we're hearing on this side, specifically within industry. And then on this side, helping to expand into the high schools to pull more people into the programs through dual enrollment and other activities. On the high school side, one of the really neat success stories we've had over the past year is we started a program called Flex Factor in high school classrooms. We started with a Lincoln High School in the fall with 8 students. We've now expanded to 200 students this semester in 6 different high schools, and we're on track to hit 500 students next year in 10 high schools across the Bay Area. The way the program works is we integrate within a classroom. It doesn't matter what it is. We've done them with English classes, economics classes, engineering, and robotics classes. It doesn't really matter. It's at the 11th grade levels, the core, but we've done it with 10th and 12th graders as well. And we work with the teacher, and essentially this is the example of what a timeline would look like over 4 weeks, where on day 1 we do a kickoff at a manufacturing facility, expose the kids to what it's like to work in those environments. We then bring them to our facility and do a entrepreneurship overview and a technology overview, and then we give them a task that says in 4 weeks you're going to pitch in a Shark Tank environment a product idea that you come up with that solves a human health or human performance monitoring problem. On the second week, we go for a tour at one of the local colleges, in this case Evergreen Valley College. They get the first entrepreneurship class from an instructor there. That instructor goes into their classrooms on each of the subsequent weeks. They also have mentor check-ins from local industry, which we coordinate for, just to get kids familiar with both the technology and some of the processes that will be required to work through their product ideas. And then we assemble a team of industry, government, academia members into their classrooms for the final pitch, and it's just like an episode of Shark Tank. And then we have some follow-up course opportunities for them to include internship coordinations with the City of San Jose and with connected companies. So it's been a fantastic program, and we've seen some great results from it. Here's the evolution I described and how fast it's grown. These are the high schools that are in effect this semester. We'll be at 200 students from the initial idea to about 8 months later, and we're really proud of that and how it's going. Here's some of the impact in their own words from some of the participants. These first 2 are students in the program from 2 different high schools. This is one of the teachers at Lincoln High School who went through the iteration we just wrapped up this morning, actually. And then you have some examples from the industry involved. This is from the dean at the local community college. This is one of the principals of the school. I'll let everyone just read those for about 15 seconds, and then I can push the slides out later if you need to. What we're really interested in is that every person involved with this process, from industry, the administrators, the educators at both the community college level and the high school level, and the students, all had tremendous outcomes and the objectives that they met from it. This is from one of the community college instructors. He's also a Silicon Valley technologist. His name's Cecil Lawson. And he really talked about how this program has been providing a number of resources to students. We had a student go through it today who said they weren't planning on going to college, but because they saw how easy it was to enroll in their local community college and the excitement they got from this program, they're now going to start full-time in the fall. And we have a number of examples like that. So where does this fit into the broad scheme of things? We're actually been talking with Marilyn, for example, Marilyn Barger from the Flate Center in Tampa, that there might be an opportunity to expand there. I'm heading to Ohio next week and really working well with Lorain County Community Colleges on another project, and we thought this might be interesting to see how it fits there. And we're working with some of our members in New York and Massachusetts to expand into those areas. And then we're looking at some folks down in Los Angeles just in the next 6 months or so for expansion. And we would love to communicate with anybody to see how we can come in and see if the programs fit inside of any community college and ecosystem that may be interested in having that discussion. So thank you very much, and open for any questions.
Marilyn, did you have a question for Brent? He talked quite a bit about the community college programs. I think you had a question in that area. Marilyn, unmute your microphone.
I was thinking we might, I think he covered it pretty well in his conversation, and just wondered if we should be moving on.
Okay, I think so. And by the way, your microphone, I think, might have slipped down a little bit. Brent, thanks very much for that presentation. I think in the interest of time, we'll keep our questions as we get to the final question period. But just a reminder, Brent, don't forget us here in Phoenix, Arizona, when you're looking for partners.
Absolutely. Thank you, Mike.
Okay, good. Thank you very much. Colleagues, let's go ahead. It's our pleasure now to bring up Noah, who's the Director of Education and Workforce Development at the Advanced Functional Fabrics of America. Noah, please tell us a little bit more about yourself and your institute.
Hi, everyone. I'm really honored to be part of this, and along with my colleagues. And I see that there actually is a question that came in for Brent right afterwards. I don't know if Brent wants to answer it before I get started.
I see it. I'll just text an answer back while you're going, Noah.
Okay. All right. So my name is Noah Drury, and I'm the Director of Education and Workforce Development at AFOA, Advanced Functional Fabrics of America. We are funded by the Department of Defense and also publicly and privately funded, similar to all the other institutes. And really what we seek to understand and find is really to transform the clothing and garments and the textiles that are around us to be of service to us, so fabrics that can see for us, hear for us, sense, communicate, store, and convert energy, regulate temperature, health, and change colors. I'm sure you're familiar with the wearable hype right now. We're in that space, and the way that we do that is by actually going down to the fiber of what that garment is made out of. Which brings us to another piece of our work, which we call Moore's Law for fibers. So similar to the semiconductor industry, where for several years the semiconductor industry experienced a new technology advancement added in each year, and actually at some points every 2 months, and each time that was introduced, a new functionality was introduced into the textiles, into semiconductors. And so we see that and we pull that and we say, okay, our fibers, which is at the fiber level, are made out of multifunctional material, which allow for them to have the capacity to heat up, energize someone, monitor health, etc. So we are very excited to see what we've been able to do so far in our short time here. So it brings us to our mission statement, which is, as you can see, we're a nonprofit, as all the other ones are, but are really at the core of everything that we do is to enable a domestic manufacturing-based revolution by transforming what we know today as fibers into highly sophisticated integrated network devices and systems. So really we go everywhere a fiber goes. So if you're sitting anywhere, actually, if there's a carpet, your garments that you're wearing, even in the walls themselves, there are textiles, there are fibers, and we're looking into entering our fibers into all of that. So for our institute's ability to transfer technology into manufacturing and to create jobs and to revolutionize the industry, it has to be coupled very closely with education and workforce development. And so these are the 3 goals that govern us in being able to do that. And just at a quick overview, We first seek to understand the current and address the future needs of industry. So we work very closely with industry on an ongoing basis of assessing their needs and understanding what they're looking for, job opportunities, job challenges. And we were part of the Department of Commerce recently released a survey to all manufacturers in the United States, and as part of our Education and Workforce Development Committee work, which actually Brent Parameter from NextFlex is actually on as well, which is a pleasure to have him on, we were able to provide feedback to that survey and add additional questions regarding workforce needs, which was the first time the Department of Commerce, when releasing this survey, actually addressed workforce needs. And specifically, we're excited to see what kind of data we get in terms of new skills, new knowledge that the textile industry is realizing that they need, so that we can address those from our technology standpoint and as well as workforce training, which will inform us about upskilling versus new trainings, et cetera. Our goal too, which is the way that we can support the technology advancement and transfer that into actual manufacturability skills, is EWD activity is specific to revolutionary fibers and textiles, and it is closely aligned with the technology program. So all the technology that comes through, the Chief Technology Officer, Dr. Amy Rose, for us here, and I work very closely together to ensure that anything that we do from Project Call, which is where our members get to help us understand what kinds of advanced materials they're able to contribute, and then we actually award new technology that inherent in that and very intrinsic to it is education and workforce development processes, so that we can capture that learning and we can develop that into production level manufacturing transference. Then the third goal, which is our continuous belief that to ensure that our work lasts beyond our time here as an institute, is to advise states on investments in areas of revolutionary fibers and textiles. And so we do this through a number of different ways, one being what we call fabric discovery centers, which I will go over in just a little bit. So this is just a high-level overview of how the EWD activity relates to the goals, and some activities that we have that help support ensuring that we are constantly through an iterative process, and that we're learning from the things that are happening, as well as developing new opportunities for us to grow our work. This is just a highlight overview of our Education and Workforce Development Committee, which I'm very proud of and very excited by the work that they've done. It's really a tremendous honor to be on this, and you can see that Marilyn Varger is on our committee, as well as Brent. And just to point out, we really tried to cross industries and really bring folks together. But the Dean of the College of Textiles at NC State, which remains to be the biggest and largest and most full of information when it comes to textiles, is on this committee. So we really get an ear to the ground when it comes to that, as well as Dan St. Louis, who is in North Carolina as well, works out of Catawba Community College in Conover, North Carolina, at a place called Manufacturing Solutions Center, which at its core was developed, and he really was helped fund this as a place for to train and provide work opportunity and workforce training for folks in order to support the changing textile industry. So the Fabric Discovery Center is, as I shared, is our way that we advise states on ongoing investments. So we were able to secure funding from Massachusetts, Pennsylvania, Georgia, on the process of New York and a few other ones, to invest locally, working with community colleges, universities, and industry to put up what we call end-to-end prototyping facilities, which co-locate prototyping, so the fastest moving technology, with education, with proximity to community colleges and university, and with partners of industry, so that together in one place you have end-to-end prototyping happening, new technology arriving in, folks have access to training that is hands-on, that's happening as the technology is developed, with community colleges and universities nearby in order to further that along. So this is something that we did a call for proposals to our members, and what we asked strategically is that if you're applying to become a Fabric Discovery Center, that you apply together as a state. And so we don't want to see competition amongst community colleges and universities and industry. We actually want to see them come together and say, the state of Georgia, the state of Massachusetts, the state of New York together have come and said, this is how we see ourselves working together in order to address this exciting revolution that's happening in fibers and textiles, and this is how we will ensure that. And that helps us paint the picture and allow for the states to have that long-term sustainability plan and ensure that the work there is coming from different places and addresses all needs across demographics of that state. So we have our Fabric Discovery Center that is for FOA headquarters and membership, as well as regional and national support. And actually, we just recently finished building it and completing it, and we'll have our ribbon cutting in June. But in this end-to-end prototyping facility, one can go from drawing the fiber, which is a specialty process that's, if you're familiar with fiber optics, similar to that. And in this case, we're putting in 3 different types of materials, which allows for functionality. And then we go all the way down to being able to actually make garments out of that in-house, as well as system integration, which is unique to our institute. Typically, when speaking about the textile industry, one does not include system integration, which is more akin to Brent's work or the semiconductor industry and technology. And because we're thinking about fabrics and textiles in a new lens that are actually providing us a service and are doing something for us, we're bringing in the system integration component of ensuring that when that product leaves the door, it actually monitors your health accurately, that it's washable, that there's kind of reimagine no sensors, but really everything is down in the fiber itself and creating circuits there. So it's a pretty exciting new addition. And that map, that's very, very small. On the left there, it actually shows you our entire ecosystem of all of our membership across the United States. And I'm proud to say that as of today, we have 105 members that span across all of industry, academia, and as community colleges, as well as startups, which startups are the biggest percentage of our membership. We have a big investment, as Brenda shared as well, in entrepreneurship and belief that to invigorate and bring innovation here, we want to focus on bringing non-traditional players, folks from across all different types of industries, experiences, to be able to experience and bring in their ideas into the space. And the more that we do that, the more innovation will take place. This is a very high-level overview of how EWD programming works for us at our institutes, with the ultimate goal of preparing students, technicians, engineers, and researchers to build productive careers. And so we go all the way from anything that we do that can be shared online is shared online in terms of short courses, seminar, project call learnings. We are working to understand what kind of credential certificates would work for our industry, as well as, and then it goes down into specific to HQ, and then industry partnership, apprenticeships, and immersion programs and job placements. I'm going to skip here and be mindful of time. I wanted to just get a chance to show you something that we're excited to share, which is our learning portal. And this is an example of, let me share my screen. All right.
No, it's coming up. I'll let you. Yep, we see it. Looks good.
Okay, great. And I've been told that if you're able to make your screen large, or expand it all the way out, then you'll be able to see the image on my screen share better. So I'm not 100% sure how to explain you how to do that. I don't know, Mike, if you want to explain that, but just so you know, in case you can't see it. So our learning portal's purpose is to ensure that all of our members have access to the capabilities that our members bring to the table in terms of prototyping and anything that's related to of FOA's mission space. So that could also be training and services that they have. They have a place where they can access that across the entire supply chain, so that they can collaborate on work, learn from each other, and ensure that this is a space that a member can come to from a place of knowing and a place of wanting to learn. So we kind of very simply kind of say that, every single one of us has something that we do, that we know how to do. We have something that we are learning, and there's something that we may be willing to or able to teach. And so we kind of go off of that to structure our learning portal. So I just wanted to give you a little bit of a demonstration of what this looks like. So this is this map of the United States that you can see is all of our members across the United States. The little icons represent the type of member that they are. So the light bulb one is startup, the green one is industry, blue one is academics, and this multicolored one that looks like a target is what we call FIN. It's a Fabric Innovation Network member, which in short means that they have manufacturing ability skill set or prototyping that they are offering to AFOA members that they're able to use their facilities for. And so this space is a place for folks to come to that are across the gamut, that are interested in either making a product, learning how to make a product, access knowledge of someone, of an expert in the field, and develop a better understanding of what's out there. So this is the first of its kind of this industry that takes you all the way from CAD IT to fiber yarn devices to textile system assembly to system integration. So just to give you an example, say I wanted to learn about, which of our members have a capability in fashion wear. So I would click here, and then the map just, if you could see it changing, it actually just filtered out to show me which members have indicated that they have core competency capabilities in being in production or an area of expertise or teaching in fashion wear. So I'm interested in learning a little bit more about those core competencies. So now I can actually move across here and see under core competencies, specifically say I'm interested in learning or applying or developing my prototype to actually have interconnect capabilities, which is an area that's unique to AFOA. I can now go back up to the map, and now the map is filtered down to me again. So within fashion wear and interconnect, which is textiles that can actually connect digitally and have a circuit within them, I'm now able to see which of our members have those offerings and start to go directly to that member's page. So let's take that example of electronics. That actually takes me to learn a little bit more about their capability and what it is that they're offering. So that's one angle, and there's a whole bunch of market applications there as well. The other piece here that I'm excited to share with you all is
No, it's Mike. I just want to be mindful of time on your presentation. So.
Yeah, what's my time?
You probably should start wrapping up, but thank you.
Okay.
Okay, thanks.
All right, so just show this. So this is where I think this is the most helpful in terms of another perspective here for our technicians. So we have a commitment to capturing every single piece of learning that happens in our projects here at headquarters that we fund, as well as in our membership. And so this is our place where across the supply chain, so you can go into any of these supply chain areas to actually learn learnings that have happened in projects. And so the way that works is that there's another tab here that lists all the projects and products that have been made at AFOA. And one can come here to actually learn how that product was made, who made it. And so just as an example, and I please ask that this is all proprietary information, but I wanted to show it. So one can actually come here, learn who made it, see the performers that were involved in it, as well as the related learning topics, so that they can actually learn how it was made, who made it, and be able to continue their learning. And so this is a space that we are very committed to anyone in the industry being exposed to this learning. So I'm going to close off there, and if there's any other questions that I can answer while next presenter goes. Thank you.
No, thanks you very much. That was quite an exciting and elaborate portal that you've developed there. I think that'll really help you going forward.
Oops.
So I think, no, in the interest of time, I'm going to go ahead. We'll save our questions for timing at the end. Folks, if we do run slightly over time, that's okay. Of course, you're welcome to disconnect if you like, but if you wish to stay with us for a few more minutes, because our final speaker, Pam Carpenter, I'm going to advance her slide right now, is coming from us from Power America. Pam, welcome. Why don't you go ahead and tell us a little bit about yourself and Power America, and then take us forward.
Great. Good afternoon. I'm Pam Carpenter. I'm Director of Education and Workforce Programs for Power America and also for the National Science Foundation Future Renewable Electric Energy Delivery and Management Systems, and I'll explain that merger in just a couple of minutes. I'm also faculty in technology, engineering, and design. So we were started in 2015 And our goal is to accelerate the commercialization of wide bandgap semiconductor technologies, making them more efficient, more cost-effective, smaller and faster, and more energy efficient using silicon carbide and gallium nitride. And we're headquartered at North Carolina State University in Raleigh, North Carolina, and we have 10 partner universities as well. So what is wide bandgap power electronics, and why is it important? We've been using silicon for a number of years, and we have tapped out of that. And as I mentioned, we want to have an adoption and accelerate the commercialization of wide bandgap semiconductor technologies, which are used from personal devices all the way up to what you're looking at here is an inverter for an electric vehicle, and in there, that tiny semiconductor that you see is made by Cree with silicon carbide. It's making it lighter and certainly more energy efficient and smaller. So the growth of the wide bandgap market will generate new jobs that require people to possess the necessary advanced skill set to design, manufacture, and also install and repair wide bandgap components and products. So here's what our mission looks like as far as career pathways, is to assist educators and trainers, but also our industry in building an education ecosystem for individuals to work in the next generation of wide bandgap power electronics. And so I'm going to go into how our programs have worked together. The Future Renewable Electric Energy Delivery and Management System is an engineering research center funded by the National Science Foundation for the first 10 years. And it houses power electronics and power systems. And we're also bringing together research, industry, and education from pre-college to postdocs. So our grand challenge is to modernize the distribution grid. So we share a lot of the same students and faculty between this Engineering Research Center and also with Power America. So we've been collaborating the last several months. Freedom is in year 9. We just finished up our site visit last week. And so we've had experience and success in a lot of our education programs. And so we started collaborating, as I mentioned, several months ago. On the left, in red, you'll see Power America's focus is on short courses and tutorials for working professionals, graduate education, and undergraduate education. The Freedom Systems Center has sort of the same alignment as far as graduate education and undergraduate education. But in addition to that, we're recruiting out of community colleges engineering programs that are 2+2 programs and have been successful with students matriculating into our university partners. We also have pre-college programs that go on during the summer where we're training teachers and high school students and middle and high school teachers. And then we also do a lot of outreach, and outreach can involve going to a community college, a K-12 school, or actually doing a College of Engineering career fair. So in March, we decided to merge all of these education programs together. And again, Power America focused on these short courses to really get out there and train the workforce, the people who are already working in the field that are engineers, short courses, webinars, workshops. We also have graduate education and undergraduate education, and I'll show you what those numbers look like in a moment with all of our partner schools. And with undergraduate education, we're really working to get them involved in hands-on internships and co-ops. Freedom is focused on middle and high school, and we also have undergraduate research scholars programs both in the summer and during the academic year for both Power America and Freedom. So here are some of our accomplishments. These are the number of graduates that were enrolled in power electronics courses. You can see all of our partner universities around the country, and we have 263 undergraduates in power electronics. But what's really changed in this past year is the increase of the number of graduates and also undergraduates involved in hands-on training in wide bandgap power electronics. So they're working under faculty in these areas, either in a research lab setting or they're working on a senior design project. Like the Engineering Research Center, we are working with our students to have the attributes of the Engineer of 2020 as established by National Academy of Engineering. And where it says skills at the top, it should say technical and analytical skills, and also creativity, communication, developing those professional skills is really important. And certainly when we've had our alumni come back and speak to students, that one of the things that they talk about is you've got to be able to have these professional skills, work across disciplines, and also communicate as well. New programs that we're really excited about include the wide bandgap power electronics module that's being developed and will be integrated into our 2017 summer programs, which include pre-college and undergraduate research. But also we have a program called Sustainable Transportation Education Program, which is teaching and training middle and high school teachers about electric vehicles and about the infrastructure that supports that. They bring this to their classroom with their students here in North Carolina, and then we actually have a competition held at North Carolina State University. So we'll be integrating that, and also we have lab training experiences for our undergraduates this summer, and enhanced proposed power electronics and semiconductor concentration in an MS in electric power systems engineering program. And so I'll jump into the college program because this is one of our target areas, and certainly we have been enhancing our undergraduate and graduate programs that will produce the next generation of power electronic engineers who will advance power electronic systems using wide bandgap technologies. I'll go back to an undergraduate program that we have here at NC State that was started several years ago in renewable electric energy systems concentration. Renewable energy is very appealing to the millennials, but in dealing with renewable energy, we're introducing students to the fundamentals of power electronics. Enrollment in this program has been growing and strong. It's around 60, and we're enriching existing courses by introducing wide bandgap design, integrating that into power electronics. We have master's and PhD programs in power electronics. Both are really strong programs. Current enrollment is here. What's unique is that we have a Master of Science in Electric Power Systems Engineering with a wide bandgap power electronics concentration. The Master of Science in Electric Power Systems Engineering program was started about 6 years ago, and it was funded by the Department of Energy to address a critical need for workforce training in power systems. It is a non-thesis program. It is very hands-on. It's to get it's workforce training. It's to get these students a master, but also with the professional skills and get them out into industry. So in 2014, we added the wide bandgap power electronics concentration into this. So those numbers are going up as well. So those students are learning about devices, packages, doing a capstone project versus a thesis, and also manufacturing and fabrication. So I'll stop at that. I wanted to be quick. Thank you very much.
Thanks very much, Pam, for helping us keep on time there. Folks, as you see in the chat window, we're just slightly over time, but hang with us for a couple of minutes while we wrap up today with questions. Marilyn, let me invite you back to the stage and ask you if you have questions for Pam. Let's start with Pam, if you might have something for her.
Sorry, just getting unmuted. Thanks, Pam, and thanks for getting us a little closer back to our time. I was interested in, I know you had, I had talked to some of your technology people, I guess it was last year at the Institute, and they were talking about a training lab or training line for technicians somewhere in a nearby college. Is that something you're looking to go back to in the future? It didn't sound like you had a focus on that concept right now, and I'm sorry if I'm putting this out to you without you maybe knowing about this, because it wasn't you involved in the conversation, but
Sure.
maybe you know something about it.
No, well, it's interesting because my last meeting of the day today is to meet with some people to try to find some funding to do that technician training. We've been charged with this focus on training the existing workforce as far as engineers with the tutorials and the short courses, the graduate and the undergraduate education. And while I'm recruiting out of community colleges into engineering programs, I think that's an important piece, and that's something that I would like to see put back into the program at some point. But thank you for that question.
Oh, awesome. Thank you. Sounds great.
Marilyn, I had a question from the audience. I'm not sure to address it to, but we'll just try, as we wrap up here today, I'll try Brent first. It sounds like these people, I'm saying this tongue-in-cheek, Marilyn, have a lot of money. So could we as community colleges write a letter to Brent and say, Brent, will you give us money to help support our program at our community college? Brent, does it work that way?
So not exactly.
Not exactly.
Yeah, but so we do have funds. We have to be cognizant of them. What I think a better way to look at it is there ways that we can partner with local community colleges all across the country into the local ecosystems where maybe we help put in money on an initial investment in a cost share role with the community college, but does that then turn into something that can grow into a broader grant generating or some activity where we can become revenue neutral over time, which is one of our goals. The funding we have is primarily for the technical project call process. It's all done on a one-to-one cost share. We can do education, workforce, entrepreneurship, and training activities with that funding, but we need to see a pathway or build a pathway together with our partners that we fund to something that turns into a revenue neutral activity in the long term. So it's probably a little bit broader question, and happy to connect on that one-on-one as well.
But that's a good response, Brent, because it really drives a partnership, and that's critical to us as we seek our own funding, is to have those partnerships as well. So that's a good point. Marilyn, we're right at the end of our time. Let me just click to the next slide, and then I'll ask you for a closing comment. I want to remind our colleagues that on June 14th, at the same time, 2 p.m. Eastern, there's going to be a second webinar in this series, and we'll actually address some of these questions that have appeared in the chat window. We're going to hear from our colleagues at ATE centers and other places that have begun work with the institutes themselves. So we'll have more chance to talk about this. Marilyn, would you like to give a round of thanks to our great presenters today and close us out?
Sure. Thanks, Mike, and thanks to Brent, Noah, and Pam for bringing this information to us and our audiences. Lots of interesting things going on. And yes, relative to a lot of us, they have, looks like a lot of money, but remember a lot of that's focused on research and development and getting new technology into the marketplace. I want to thank all of our listeners and participants. If you're interested, of course, there's a nice webinar for Manufacturing USA Institute. You can look at manufacturing.gov and navigate to the institutes and learn more about each of the individual ones. Remember, there's many more besides the 3 that had the opportunity to talk with us today. So thank you, and we hope that you'll join us next month.
And also our thanks to Celeste Carter from the National Science Foundation for joining as well. We always appreciate her support. Colleagues, help us today with one last thing. As you exit the webinar, I'm going to launch the survey now, and it asks you just 3 little questions about today's webinar, so just take a minute. It'll open in a separate browser window on your screen. You'll still be able to hear me, But please go ahead and answer those 3 questions. Just click the radio buttons and hit submit. As that's going on, I'll kick in the closing music for today. Thanks for joining. I hope you can join us again on June 14th. Goodbye, everyone.